Notes 5.1 are on solving systems of equations graphically. When you look at what comes next in the video, it will say notes 4.1. Just ignore it and just keep watching. You're on the right set of notes. You're doing exactly what you need to do, okay? Okay, notes 4.1 are on solving systems of equations graphically. By the time we're done with this unit, we will learn how to solve systems of equations using several different methods. Today's lesson is on solving them by graphing. So before we do that, let's look at question number 1. Circle all ordered pairs that are solutions to the equation 4x minus y equals 10. Now, normally we would isolate the y, but I just want to know, are these coordinates actual solutions or not? All I have to do is take my values and plug them in. I know that x is 3 and y is 2 in this specific example. So then I can just figure out what the answer is going to be just by plugging it in. So when I plug it in into 4x minus y equals 10, that means I would do 4 times 3 minus y, which is 2, equals 10. So I get 12 minus 2 equals 10, and 10 equals 10. So it works. So I know for a fact that 3, 2 will fall in the line 4x minus y equals 10. I can also do this just by graphing out my lines and seeing if these will work. The next one, 2 comma 3. Let's see if that one's going to work. So I'm going to say 4 times 2 minus 3 equals 10. 4 times 2 is 8. 8 minus 3 is 10. And then I end up getting 5 equals 10, which is not true, so this is not a solution. All right. Let's do this next one together, and then I'm going to have you do the last two on your own. So the next one, I would do 4 times negative 1 minus negative 14, because that's the y value, equals 10. So you get negative 4 plus 14 equals 10. So then you end up getting 10 equals 10, and it works. So this is one solution. All right. Go ahead and try the next two. Press pause and then come back to me when you're done with the problem. All right, go ahead, take a look at the work that we have here. For this one, you should get 10 equals 10, and then for this one, you should get 8 equals 10. And since this is true, you circle it. Since this is not true, then 3, 4 does not fall on the line. All right, question 2. Find another solution to 4x minus y equals 10. So you can really make up any solution you want. So I'm going to just make up the x is 5. So if I were to do 4 times 5 minus y equals 10, I would get 20 minus something equals 10. Well, that something that I need is a 10. I could solve it, okay, but I'm not going to spend the time doing that. So that means that 5 comma 10 is a solution, right? Go ahead and find another solution and see what you get, and then come back to me. Okay, so hopefully you should understand that no matter what you plug in for x, you'll have a corresponding y value, so that way that the line has multiple points on it, right? If I were to graph the line out, it would end up looking like this. I have multiple points on the line. I can choose anywhere on the line and there'll be a point there, so that means that there are infinite solutions to 4x minus y equals 10, okay? So in one line, you have infinite solutions, right? If I were to draw another line, I would have infinite solutions on this blue line, right? But if I were to extend this line right here so you can see it, the red line has infinite solutions, the blue line has infinite solutions, but the intersection, the two lines together only have one common solution, okay? So this is the one solution that satisfies both equations. So the definition of a system of equations is just a set of equations that has one simultaneous solution. That means one solution that satisfies all the equations at the same time. Now this is what you need to understand. If there are two variables, for example in question number 4, there are two variables in the first equation, x and y, and there are two variables in the second equation, which are both x and y again. If there are two variables, you need two equations to solve it. If you have one equation, it's not enough information to solve it. If there are 4 variables, you would need 4 equations to solve it. If there were 20 variables, you would need 20 equations to solve it. For this class, we're only going to deal with 2 variable systems of equations. So let's go ahead and talk about what we need to do in order to solve this. Literally, all I have to do is graph out each equation, okay? In question number 4, the y is isolated in both equations, so I'm good to go for these graphs. I can just graph them out. So the first graph is y equals x minus 4. So all I have to do is start right at negative 4, okay? And then I would go up 1 over 1, up 1 over 1, okay? And if I were you, I would put as many dots as you can, because sometimes your ruler might be off a little bit, and then it will mess you up for where the lines will intersect with each other. Then you just connect the dots, make sure that you have your arrows, and you write your equation right on the line, okay? Now remember, there are infinite solutions on this purple line. Now I'm going to graph out my other line, which is y equals negative 2x plus 5. So I'm going to start right at 5, and then according to the slope, I should go down 2 over 1, down 2 over 1. Make sure that you keep going with your dots so that way you can see where they truly are going to intersect with each other, okay? Connect your dots here, and then you'll end up getting your second line. So you should have connected the dots, extended the line, put your arrows, write your equation on your line, all of that kind of stuff. If you fell behind, just press pause and catch up and then come back to me. So right here, the pink line also has infinite solutions, but there's only one solution that satisfies both equations, and that's right here. So this solution is your answer to your system of equations. So your answer is 3, negative 1. Make sure you identify that this is the answer, because that's really all we care about. When it says to solve it, you got to get an answer. Now that we've done that, let's do our check. So in order to check, I'm going to write the equation down, y equals x minus 4, and every time I see a y, I'm going to replace it with negative 1. X is going to get replaced with 3. So I end up getting negative 1 equals negative 1. Now, a lot of people think that once they do this one check, they're done. But you're not, because I could have plugged in any point on this line and it would have worked, but only one point works for both lines. So you have to check the other line. So y equals negative 2x plus 5. Let's check it. Every time I see a y, I'm going to replace it with a negative 1. I'm going to replace the x with 3 minus 5. So we get negative 1 equals, plus 5. I get negative 1 equals negative 6 plus 5, so I end up getting negative 1 equals negative 1. Check. I'm 100% sure that it's right. Okay? Now let's take a look at question number 2. In question number 2, question number 5, the first thing that you need to do is make sure that you isolate the y in both equations. So let's isolate the y in the first equation. The equation is 3y plus 18 equals 6x. So I'm going to subtract 18 from both sides, and I end up getting 3y equals 6x minus 18. Divide both sides by 3, and your equation is y equals 2x minus 6. Now that I've gotten that done, I can go ahead and do my graph. So I'm going to start at negative 6, and then I'm going to go up 2 over 1, because remember, your slope is always a fraction, okay? And the denominator of that 2 is 1. Connect your dots right here, and you'll have your line, but make sure that you go up 2 and over 1 and not up 2 and over 2. Sorry about that. So go ahead and connect your dots, and then this is the line that you will end up getting, just like this. Okay, and then we'll say that this is y equals 2x minus 6. I'm going to put it down here. And then let's do the same thing with the other equation. The other equation is x minus y equals 4. So let's go ahead and write that out and solve for y. So the first thing I'm going to do is I'm going to add y to make it positive. So I get x equals 4 plus y, okay? I'm sorry, this gets written out kind of strangely. This should be a positive 4. Then you're going to subtract 4 from both sides, and you end up getting x minus 4 equals y. So for this one, I'm going to start at negative 4, and I'm going to go up 1 over 1. Up 1 over 1. And it's very clear after you do a couple of them where they're going to intersect with each other. So this is my line right here. Connect the dots. Draw your arrow. You end up getting y equals x minus 4, but the most important piece is your solution, which is where they intersect. So my final answer to this is going to be 2, negative 2, and that's my answer. I'm good to go.